So this is 1.5. Again, make sure that you do the practice problems on the quizzes. That prepares you for the actual test. So what is banking? Banking is the business of protecting money for others. So what are different types of banks and financial institutions? You can make a chart, show common types of banks, and a little bit of information is on that website. Here's just a couple of things. The common types of banks, you got commercial. So these are the places like you can do savings, checkings, etc. Credit unions, this is where you can get loans and like credit cards and stuff to pay for really expensive things. Thrifts are a type of bank. Okay, so you can look at the different types if you want to at that website. I'm not gonna sit here and list them all out for you, but all right, what are some typical services that the banks do? They do loans like house loans, car loans, etc. They do checking and savings accounts. And then they do insurance. Now, there's a couple of other things that they also do. Again, you can look it up on that website. But these are like the main things that you do as an adult. Okay. All right. So on the next page, what are some things to consider when choosing a bank? This is really important. Okay. So the kind of services they offer, the location. So if you have, a bank in Alaska, that doesn't do you any good because sometimes you do have to go in person. Whether or not they're federally insured. You don't want some like podunk looking weird bank and then give them all your money. Okay, because banks do go out of business. And then Federal Deposit Insurance, that's what this stands for. Federal Deposit Insurance Corporation, and then the National Credit Union Association. So you want to make sure that they're federally insured. Now, James is borrowing $2,000 from his employer and will pay it back at the end of 3 years. The employer lending the money asks that James pay simple interest of 3% annually. Using the simple interest formula, I equals PRT, determine how much interest James will have to pay back in addition to the $2,000 principal amount. So we're trying to solve for I. I put I too many times. There we go. All right, our principal amount is 2,000. Our rate, we're going to turn it into a decimal, 0.03. And then we're going to do it for 3 years. So that'll be $180. So he'll pay $180 on top of that 2,000. Okay, so that's why like borrowing money is such a profitable thing for some people, is because the amount of time that you spend holding on to that money, it costs you more. Okay, and the next one says Ryan is investing $9,000 into a CD at a bank. Okay, if the bank uses simple interest and the bank pays 3.1% annually, how much will the CD be worth at the end of 5 years when the CD matures? So again, same formula. So 9,000 times 0.031, because that turns into a decimal. And then we're going to multiply it times 5, and that gives us 1,395. Now, the CD will be worth 9,000 plus the 1,395, which is going to give us 10,395. Okay. Flipping over to the next page. We're starting to talk about something called compound interest. Okay? So compound interest is this little formula right here, okay, where P sub 0, this is the initial amount. Initial. R is the rate. P is the number of years. And then N is the number of times that it's compounded. So this could be annually, monthly, etc., which we're going to fill in that table in just a second below. Okay. So the account that Jim is putting into $15,000 into a high yields savings account that pays 2.8% annually. So it's compounded annually. Okay, that means once a year. If the bank uses a compound interest formula, how much will the account be worth in 5 years? So looking at this, I'm going to plug in. So our initial was 15,000. And then I have 1 plus 0.028. And we're going to divide it by 1. And we're going to raise it to the power of 1 times 5. Okay, because 1 is annually, and that 5 is the 5 years. When I plug that into my calculator, I'm going to get 17,220.94. Okay. Now, Jim saw that other banks offered him the same rate, but compounded interest more often. Compounding interest more often, you actually sometimes make more than just once a year. Okay, so semi-annually is twice a year. Okay, so N is going to be 2 on that one. Monthly is 12. Quarterly is 4. Weekly, there's 52 weeks in a year. Daily, that's 365. And then continuously is a little different. We're going to talk about that in just a second. So if I have N in here as 2, this is what my problem should look like. And when I plug that into my calculator, make sure you use parentheses, especially in that exponent, you should get that. So if you'd like to pause the video, then try plugging all of these into your calculator and then checking your work. All right, so these are the numbers that you should have gotten on the right-hand column. Okay, if you didn't get these, again, check your work, make sure you use parentheses, all that fun jazz. Okay, now continuously is a different adverb. It is talking about a formula, which is down here at the bottom, with P, initial value, raised times E raised to the RT. So this is going to be 15,000 E, which that E is going to represent 2.71 or 72. This is called Euler's number or Euler's number, depending on who you're talking to. We're going to raise that to the 0.028. We're going to multiply it times 5. When we do that, we're going to get 17,254.11. Now that's the biggest one. If you get a continuously compounded thing, then it makes it worth the while for sure. Okay. All right, take a look at the next page. And on that next page, see if you can plug in to that formula. All right, so Marissa wants to invest $4,000 into a retirement fund that guarantees a return of 9% annually using simple interest. So you got to pay attention to which formula it's asking. So your initial is 4,000. Your, I'm sorry, whoopsie. Your initial is 4,000. Okay. And then your rate is going to be that 9%. So we're going to turn that into a decimal. I'm trying to find how long it's going to take her to double. And our final amount is going to be 8,000. Okay. Sorry. Okay, so simple interest. If we have our final is equal to our initial plus our investment, okay, then that means that we're going to have 8,000. Write this meter. This is going to give me 8,000 as our final because we want to double, right? Our initial was 4,000 plus we got our interest rate. So we've got that formula. We got P equals or I equals PRT, right? So we're going to do 4,000 times 0.09 T. Now we're going to solve for T. So we're going to subtract that 4,000. That's going to give us 4,000 over here. And then we're going to have 4,000 times 0.09 times T. We're going to divide by 4,000 on both sides. And that's going to give us 1 equals 0.09 T. Now, if we divide by 0.09, we get 11. So T is going to equal 11 for this first one. Okay, now on the next one, it says determine which investment is better. Evan's plan to invest 10,000 for 8 years. So Better Banks offers 8-year CD at an annual rate of 5% using simple interest. So we got interest equals 10,000 times 0.058, and that's equal to 4,000. So he's going to spend 10,000 plus 4,000, and that's going to give us 14,000. Or the next one, it says compounded monthly. So we're going to use that formula of 1 plus R divided by N raised to the NT. Our initial is 10,000. Our rate is 0.047 as a decimal. We're going to divide by 12 because it says monthly. We're going to raise it to the 12 times 8. When we plug all that junk into our calculator, and I highly suggest you use Desmos on that one, we're going to get 14,553.78. So that's better than the first one. Now on the last one, it says Union Bank offers 8 years at 4.5% using continuous. Okay, so continuously compounded, we're using that formula where we got P equals P, initial P, E raised to the RT. So that's 10,000 times E raised to the 0.045 times 8 years. When we plug all that junk into our calculator, we're going to get 14,333.29. Okay, so which one? Better Bank, America's Bank, or Union Bank? Well, America's Bank, that's the second one, is the best because it gets the most money. Now, 10 years ago, Josh put money into an account paying 5.5 compounded continuously. If the account is 12,000 now, how much money did he deposit? So if it's 12,000 now, and our rate was 5%, 5.5%, and we did it for 10 years, and now we're trying to solve for our initial. So we're going to take 12,000 and we're going to divide it by E raised to the 0.055 times 10. Remember, E is just a number. It's like almost like pi. So this gives us our initial amount. If you plug this into your calculator, make sure you use parentheses. You're going to get 6,923.40. Okay. And that's lesson number 5.